Hello guys, welcome you all for this session on AIML end-to-end session where we're gonna learn everything that we required in order to become a successful data scientist, guys. So yeah, everything gonna be a scratch manner and very easy manner. So please subscribe to our channel so that you do not miss any of the session. So please guys, please watch to all the videos previous to this session so that you have a greater understanding of what we are teaching now. Okay. So this is a continuation session. Please watch to both of the previous videos so that you can have a better understanding what we are doing now. Okay, so what we're gonna see today is right, the first thing is handling missing data and outliers. So we are having different ways of handling this missing data and outlier. First is imputation. Okay, replacing missing values with estimated value based on available data. Okay, like using mean median mode, we can just replace the existing data. Okay, deletion, removal of rows and columns with missing values, but only if the data loss is minimum. Okay, that's right. Okay, whenever you are having minimum loss when you go for a deletion, then you can use the deletion. Okay, outlier deduction, identify data points that deviate significantly from the rest of the data set. Yeah, so if a data point which is far away from a data set, that is very far away from the mean, then it is considered as an outlier. Outlier treatment, handling outlier by removing them or replacing them with more representative values or transforming the data. So this is a way that you can treat the outlier. So this is a way how we can handle the missing as well as outliers data. Okay, so yeah sir, over to you.
Yes, handling missing data and outliers. First, we need to do imputation, which is replacing missing value with estimated value based on the available data. So then we have to do deletion, removing rows and columns with missing values. Okay, but only in the data if the data loss is minimal. So your data loss should be minimal for when you are going for deletion. Okay, outlier detection is identifying data points that are uh, that deviate significantly from the rest of the data set. So outlier is like it is always out, it is outside the median, mode and mean. Okay, so they are very away from the plus minus. Okay, so both like they are always away, they will be extremely negative or extremely positive. So they are not in that curve, so normal distribution and it's not, they are not around the central values. You will see they are always, so we have to identify them. Okay, and which will help us. So outliers treatment is handling outliers by removing them. We have to remove them, replacing them with more representative value or transforming the data. So this is how we can do outlier treatment. So first is to find the outliers detection and then the outlier treatment. So this is how you manage handling missing data and outliers in data science. So keep learning deeply. If you have any suggestion, feedback, so kindly write to us. So we are enjoying these sessions, we are loving. So write in the comment section how you are feeling. If you want any improvement, so write to us, and go and watch all the sessions 5 to 10 times and absorb the information, digest the information, and apply. So do all the assignments and continuously learn. Have patience, persistency, consistency. Keep learning. Thank you. Let's move to the other slide.
Yeah, sure. Next is scaling and normalization of data. So scaling means I think we have already discussed about this, right? So in order to make the model to generalize everything, we need to go for a scaling kind of thing so that we can avoid the bias in the model whenever we are having data. First is scaling. We just adjust the range of features to a common scale like such as 0 to 1. So making all the data to be in the same scale so that the model can understand everything in the same manner. Then normalization, transforming features into have a specific distribution such as standard normal distribution. Okay, where the like we will be having standard deviation of zeros and mean one. So like that we will be having a fixed value so that we have a proper bell shaped curve. Okay, for normalization. Then impact. So This scaling and normalization helps algorithm perform better and prevent bias. Okay, so the thing is, once you apply the scaling and normalization to the data set, it becomes the data set becomes very common and very generalized. So that whenever you build a model on top of it, it also becomes very generalized. Okay, so whenever you have a data, try to use this scaling and normalization to make the data normalized. Okay, so yes, sir, over to you. So that's the reason, guys. We will be using, so whenever we are having a data, right? So if we are having data of different ranges, what happens means whenever you need to build a model, the model cannot understand. Okay, this is the range that we are using. So it doesn't have an idea of okay, um, would this is max or this is min. So in order to make the model to understand this is a max and min, and this is what the scale I am using, then you can use this scaling and then normalization. Okay, so yes sir, over to you. Like, is there anything that you need to add for this?
Yeah, so again, guys, scaling and normalization of data is very important. We have to do scaling. So, adjusting the range of features, we have to, you would be having scale at your home, you've used it, right? So, same sense, we have to bring data to a same scale so that we can measure it properly and we can uh, common scale such as 0 and 1. So you bring all the data, okay, according to that. So normalization, again, transforming features to have specific distribution such as standard normal distribution. So we need to have that, okay. So you can see picture above. So that is normally distributed, so you have to do normalization. Then impact, scaling and normalization helps or algorithm perform better and prevent bias. So when it is, so you'll see both sides, you see it is positively distributed, negatively distributed. Look like you can see both sides equally. So when you have this kind of, so you really, if you get data only positive, that we call it positive skewed. So negative is skewed. So that should not be there. It should be normally distributed from plus minus baseline. Like it should be scattered mm, uh, on the around the baseline, both the sides. Okay. So then once we do scaling normalization, the impact is our algorithm is not biased and it will, the performance will be very nice, huh? So normalization and scaling is, they are very important tools, guys. So in your machine learning, in data science and deep learning, they are very powerful, and because of them we have great models and we can create great projects and applications. We can use them, and they are the, like, they are, what I'll say, they are the heart and soul um, um, of your data science and machine learning and deep learning. Because when you do scaling and normalizing, you understand, you normalize the data, you scale it properly, and then it will perform well. Thank you.
Yeah, that's true, sir. So whenever you have a data, you need to like scale the things so that only we can do further analysis or modeling kind of. Okay. So let's see the next topic. Dimensionality reduction case. Actually, we have seen this in the previous session. Like, what is meant by dimensionality reduction? Okay, so dimensionality reduction is a form of converting a higher dimensional data to a lower dimensional data. There are different ways we are available. One is PCA, principal component analysis, which finds the principal component that captures the most variance in the data. Next, LDA, it's a linear discriminant analysis, which finds the linear combination of features that maximize class separability. Okay. Next, we are having TSNA, is a T distributed stochastic neighbor embedding, which preserve local neighborhood relationship in higher dimension data for visualization. I will put it this everything in a simple way. We are making the data to be understandable for the model. In such a manner, we will just uh, reduce the dimension from a very higher to lower, so that it has a proper understanding. Whenever we are making a higher dimension to lower dimension, this lower dimension has a capability of representing all the higher dimension value. Okay, so that is what all about this dimensionality reduction technique, guys. So yeah, sir, over to you.
Yeah, so dimensionality reduction techniques are, guys, so suppose PCA. So PCA is finds principal component, like, okay, so the captures most variance in the data. It captures the most variance, okay. So so with that we can understand, we can reduce the dimensionality of the data. So linear discriminant analysis, LDA, is it finds linear combination of feature that make maximize class separability. So these techniques are very, very important. You need to understand the characteristics of your data and then apply according to that. Whether PCA will be applicable or LDA will be applicable, you have to understand, so that you can reduce dimensionality. Because you actually, why we use dimensionality reduction techniques is to remove the excessive, non-required dimensions of the data, so that we the performance of the model will be improved. If you have a lot of the features in your data, it will decrease the performance. So T distributed stochastic neighbor embedding, TSNE, that is another kind of a technique which preserves local neighborhood relationship in high dimensional data for visualization. See, so suppose you're using a nearest neighbor algorithm. So here, uh, suppose you're using that. So if you, it will preserve local neighborhood. So there it might help you for that kind of model. So you have to check it, you have to test, try, and do a lot of practice understanding these models applications. You have to run on different, you can run different models, do these techniques on different data, and then you'll understand how the behavior, how the outcome comes. So that is very important, to reduce the dimensionality of the data, so that the performance of the model improves. Okay, this is the major function of these dimensionality reduction techniques. Okay, let's move to the other slide.
Yeah, sure, sir. So the next thing, automating data transformation pipeline. Okay. So guys, actually we have seen lots of things. Okay, but the end thing is like you can see for the last 2 to 3 sessions we will be having some terms like EDA, and then something like this kind of we have seen about dimensional reduction. So this everything are merging, right? It is just coming again. So the thing is, these are the concept which is very, very important in data science. So whenever wherever you take any topic, the concept will be a part of it or it gonna be the entire topic. Okay, that's the reason we are having. So automating data transformation pipeline. So first is effectiveness. Okay, so efficiency, sorry. So streamlining data transformation process, saving time and effort. Okay, so that will create the efficiency. Next is consistency, ensure consistent application of transformations across different data sets. So it will create a consistency. Okay, so reproducibility like allows for easy replication of transformation for future projects also. Once we have a, this is what the steps that we're going to do, then we can replicate. Okay, so modularity allow for individual transformation steps to be reused and combined. So this is also a reusing. So by automating this data transformation, whichever we have seen, right, scaling, normalization, like those things, removing missing value, everything, by automating everything we can make this pipeline very easier for the future data. So in order to do everything in a simple manner, and we will go for the analysis of modeling. So yeah, that's it from my side. Yes, sir. Over to you.
Yeah. So automating data transformation pipeline. So we have to understand, when we are automating the data transformation pipeline. So pipeline is like we have end-to-end process. So whatever data we have collected and all the steps we have in across the um, whatever steps and processes and phases we have. So efficiency, streamlining data transformation process, saving time and effort. We have to, when we are automating, it will help us in efficiency. Consistency, It will ensure that there's a consistency in application of transformation across different data sets. So when we automate the entire pipeline, data transformation pipeline, so it will help us in efficiency, consistency, reproducibility, allows us easily replicate the transformation for future projects. So we can reproduce again it for future projects. Okay. Modularity allows for individual transformation steps to be reused and combined. So these are the benefits, for a data transformation pipeline. Automating When we automate data transformation pipeline, so these are four major benefit: efficiency, consistency, reproducibility, modularity. So this helps the entire project and pipeline. And so uh, yeah. So guys, go deeply, watch all these sessions 5 to 10 times, absorb the information, digest the information, apply the information, do all the assignments, give us feedback, how we can improve these sessions and how impact they are making in your life, and share the results what have you understood. So that will motivate us to completely come again and again and make this big 1 year program for you. Any which ways we'll do that, but it will help us motivating more. So subscribe to our channels and write in the comment section and do all the assignments, and be consistent, persistent, and keep learning deeply. Thank you so much.
Yeah, guys, that's all about this session. So make sure that you guys have a proper understanding. If you guys are feeling any difficulties, we are here to help you. Just ping in the comments, and please subscribe to our channel. As Cyrus mentioned, like it's gonna be a year-long program, guys. Okay, we will learn together, and let us know if you guys are feeling any difficulties. So yeah, that's it from our side, guys. So yeah, bye, take care, and we will see you in the next session. Bye, guys.